So we are looking at the 10-year flood map in Florida. So this is 10-year floods plus sea level rise. Yeah, so it looks like literally everything around us will be underwater by the end of the century in a pretty normal flood. There's some residential homes here, actually a lot of neighborhoods here. I mean, I'm even seeing a crane there. There's a huge apartment complex that looks like it's about to be built. Now, these people that live in these houses they're gonna have to find somewhere to live by the end of the century. In episode 1, we talked about tipping elements that are already underway. Coral reefs and permafrost are being lost on massive scales. In this episode, we're gonna explore the harder to observe tipping points that could leave our planet and civilization fundamentally unrecognizable. I'm Maiya May, and I'm fascinated by our dynamic planet, our weather, and our climate. What began as a career in broadcast meteorology has become a mission to figure out where we are oh my God! And where we're going as we leave this long, stable climate period and enter the hockey stick era. So join me on the ocean, in a plane, and in a tiny southern town as I learn what our future will look like. Because we are truly at a climate crossroads. Whether or not we halt our planet's warming, our future will look unlike anything you can imagine.
Hello.
Hey, so good to meet you.
I'm Maiya.
I'm Lisa Beal.
Nice to meet you. This is an awesome ship.
This is our research vessel, Walton Smith. The really cool thing about the Walton Smith, she's kind of small, but she has a super low draft. So we can take her in really snug places like in the Florida Bay. For our cruise, we're gonna go out to the center of the Florida Straits though. So in the teeth of the Gulf Stream.
The Gulf Stream is a powerful surface current and a vital component of the largest heat transfer on Earth, the Atlantic Meridional Overturning Circulation, or AMOC. The AMOC acts as a global conveyor belt, moving warm surface water north and cold deep water south, helping to regulate our global climate. Recently, the AMOC has gotten a lot of attention because climate models suggest that the rapid melting of the Greenland ice sheet should lead to this circulation's disruption or even collapse, a scenario with almost unimaginable consequences.
If the AMOC tips, well, where I live, the climate suddenly gets incredibly greater seasonality, cold, harsh winters and even hotter summers. But I'd be most concerned in the tropics because we would potentially lose the monsoon in West Africa, which would be a humanitarian catastrophe, and also disrupt the monsoon in India severely, which is the livelihoods of over a billion people. And it also disrupts the rainfall over the Amazon, so threatens this crucial harbour of biodiversity and indigenous peoples. And also, when the AMOC tips, it raises the sea level around large parts of the North Atlantic. And then what's happening is it's leaving heat behind in the Southern Ocean, so it's risking bringing forward the tipping points for the Antarctic ice sheets.
Not only do climate models suggest that global warming should disrupt the AMOC, but scientists also believe that during past periods of significant warming, such as the transition out of the last ice age, the AMOC may have significantly weakened or even shut down entirely. The problem is that determining if this process has already started again has proven to be very tricky because we only have about 20 years of direct observational data on the AMOC. But Lisa and her colleague Chris may have found a solution.
In the future, under global warming, the large-scale Atlantic meridional overturning circulation will reduce with climate change. That, I think, we're all agreed on. What there's more ambiguity on is whether the overturning circulation has already weakened.
And this is where the Gulf Stream comes in. Since the Gulf Stream is a key surface current within the AMOC, any signs of it slowing down could indicate that the AMOC itself is losing strength. And in a groundbreaking study, Chris and Lisa found a way to extend the observational record of the Gulf Stream by decades using underwater telecommunication cables.
We combined a number of different observational data sets to look at how the strength of the Gulf Stream has changed over the last 40 or 50 years. And, we believe statistically, we found a robust weakening.
That finding allows researchers to compare what the models say about the AMOC with the observations of the Gulf Stream.
Over this same 4-decade period, where the climate models unambiguously say we should have seen weakening, we do see a comparable weakening in the observations of the Gulf Stream.
We put those together and say it's likely that weakening in the Gulf Stream is related to a weakening in the AMOC. And so maybe we're actually observing for the first time a robust signal, a robust weakening in the overturning.
Lisa and her team are also trying to learn about a local impact of this weakening: sea level rise.
What we're putting out in the next couple of days is the 3 moorings here. They're going to measure the carbon and the nutrients and the pH.
I gotcha.
Right?
Gotcha.
And these guys in between are going to give us the temperature, salinity, fluxes, the heat content, and the sea level.
This data, this research is really going to help you figure out how the Gulf Stream and the changes in the Gulf Stream might affect Florida.
Yeah, we're hoping to answer some of those questions as well. So some of these moorings that we put in, we're going to be able to measure how much water there is, above those instruments. And that's going to give us the sea surface height, the sea level.
And the sea, it turns out, is far from level. It's full of hills, bumps, and craters. And the most significant reason is ocean currents.
There is an intimate connection between the flow of the Gulf Stream and the height of sea level all along the U.S. southeastern coast. It's continually being deflected to the side by the effect of Earth's rotation. It turns out that how much that deflection force affects ocean water depends on 2 things. One is Earth's rotation, and the other is how fast the ocean currents are moving. The faster the ocean water moves, the more of a deflection to the side you get.
And while the Gulf Stream is mostly powered by the wind, the larger flow of the AMOC also plays a crucial role. If it were to collapse, the Gulf Stream could slow enough to add an additional 3 feet of sea level rise in places like Miami.
We do not want to be playing Russian roulette with the Atlantic overturning circulation, and it's like a crazy experiment we seem to be doing, but its consequences are so dangerous that we need to do everything in our power to try and limit the risk of this tipping point.
We don't know the level of warming that will push this system past the point of no return, but we do know that as we move further and further away from our historically stable climate, we risk triggering more tipping points like the collapse of the AMOC. Things like the dieback of the Amazon rainforest or the runaway melt of the Greenland and Antarctic ice sheets are all possible on our current projected path, 2.7 degrees of warming. And I'd rather not find out which of those lines we cross first. So I headed to a tiny town of just 122 residents in rural Georgia that might have the solution that I'm looking for.
Hello, hello.
Hey, Maiya.
How are you? We are in DeSoto, Georgia. This definitely reminds me of my grandmother's house, going up to Twinsburg, Ohio. So how do we solve climate change, in your opinion?
Well, it's pretty simple. We just have to electrify everything.
Ari's nonprofit, Rewiring America, is on a mission to do just that. Because once we power everything with electricity, we can get our energy from renewable sources.
Here's the climate future, Maiya.
This is it.
This is it.
I don't know what I was expecting, but
Yeah,
it's not an electric car.
Here's your future today.
Yes.
Yeah. This is the heat pump.
Today, most homes in the US still use natural gas. But a heat pump runs on electricity. And the more homes that adopt them, the less gas we burn.
So DeSoto is this community that has welcomed us in to basically create a conversation at kitchen tables here in town about how they can benefit from more efficient electric appliances to help them live more comfortably, save money on their bills, and actually, while doing it, tackle the climate crisis.
We've already learned that clean energy is increasing at an exponential rate. So a project like this really gives me hope, because decisions we make in the home are key to getting to net zero. But an ambitious project like this could use the help of some heavy hitters. And prominent social and environmental justice advocate Stacey Abrahms is the perfect person.
So can you tell me a little bit more about the DeSoto project?
I have had the privilege for the last year and a half to work with Rewiring America as their senior counsel. And one of my projects was thinking about how do we engage communities in the transition to electrification. But for me, the most exciting idea was to come down to DeSoto, to a small town in rural Georgia in the Black Belt. The original intent was to do a handful of homes like we're doing around the country. But when I got a chance to come down here and drive around, I called the head of Rewiring and said, instead of just doing a demonstration in a few homes, why don't we rewire DeSoto? And Ari was game, and so DeSoto became the demonstration of what we can do when we rewire communities.
It seems like Georgia has become this kind of powerhouse for renewables.
You're absolutely correct, and I think what's so important to me in this moment is that we understand what it means. Electrification is really about saying we have more efficient machines that can heat and cool your home, heat and cool your water, heat and cook your food, and we can do so where it costs you less money, it's more efficient, it's cleaner. Instead of it being a conversation about sacrifice, it's a conversation about opportunity, and that's why I'm so excited about electrification.
We're in a global race to reach net zero emissions as soon as possible, and that means getting off fossil fuels. Essentially, we need to stop burning stuff to meet our energy needs.
This is a big project, but I'm hopeful because our short-term incentives are finally beginning to line up with our climate goals, because renewable energy is quickly becoming the cheapest option.
If you had told me a decade ago that the cost of solar panels would have fallen by 90%, the cost of batteries would have fallen by 90%, the cost of wind power would have fallen by 2/3, I'd have been pretty skeptical. Like, those are big numbers. But we did.
In the US, we are rapidly decarbonizing electricity, which is one of the biggest sources for greenhouse gases. But greening the grid is the easy part. The work ahead of us is a lot more tricky.
So right now, we're seeing a lot of progress in decarbonizing electricity because clean energy is cheap. We're seeing some progress in light vehicles because electric vehicles are becoming cheap and taking off. But we're going to have to see similar progress in buildings. You know, get rid of natural gas furnaces, replace them with heat pumps. We're going to have to see decarbonization in the commercial sector and in the industrial sector. And there's some sectors like agriculture that are just going to be really hard to fully decarbonize.
Another one of those really hard to decarbonize sectors is aviation, which accounts for about 9% of our transportation emissions. But even here, we're starting to see real tangible progress.
So this here is Aaliyah, and Aaliyah is a fully electric vertical takeoff and landing aircraft.
This is absolutely amazing. Walk me through it. I'm seeing all these big propellers. This doesn't look like a traditional aircraft.
For most of aviation history, electric planes weren't viable because batteries were just too heavy. But energy storage has gotten lighter, and Beta's aircraft needs less energy because it slides through the air more efficiently than older planes. One of their first real-world use cases is shipping packages. But since not all distribution centers have airstrips, they designed a plane that takes off and lands vertically. And I got to fly it. Well, kinda.
We've got our Aaliyah 250 aircraft teed up in the high-fidelity simulator to teach you how to take off and land from your home field, Atlanta Hartsfield Airport.
I'm so excited.
All right, let's do it. And you're gonna get right into that right seat.
Okay.
And then I'm gonna hop in the left seat, and I'm gonna talk you through some of the avionics and flight control systems so we can get airborne here in a second.
I've never done anything like this.
You see about 7, yeah, right about there. Okay, let go of everything. So with your right hand, just twist and hold, and that's how you control the yaw.
This is so realistic. This is not moving at all. But when I'm turning, like I feel like I'm moving.
You actually feel like you're flying.
And I have to say, even though I'm a nervous flyer, it was so cool to be in front of the controls.
Add a little power because we're coming down pretty good, right about there, and just let it settle. You do better than some of our test pilots, Maiya.
Really?
All the way down, push it all the way down now.
Oh, all right. I just flew and landed an electric plane. Oh on pilot. Paint a picture of beta fully realized.
Aviation is at like this really interesting inflection point of change. So we have a long ways to go. We have the class of aircraft that I just showed you moving things efficiently between hospitals and package delivery centers. We have larger aircraft moving passengers regionally in the next decade and then across the entire country in the next 20 years.
So you're telling me that in, say, 20 years, I'm gonna be taking a flight from Atlanta to LA in an all-electric plane?
Absolutely.
And this change is happening on a national and global scale. We all know electric vehicles have been taking off recently, but there are bigger plans in the works.
The Aspire program, for instance, is developing a network of electric highways that can charge vehicles while they drive. At the same time, batteries are improving at an exponential rate. This means more of the energy generated from renewable sources like wind and solar can be available when the sun isn't shining or the wind isn't blowing. And we're seeing new kinds of energy storage. Green hydrogen, for example, only emits water as a byproduct and is emerging as a key power source for the most challenging sectors to decarbonize, like aviation and shipping. And gravity batteries use excess electricity from renewable sources to lift up heavy objects, then generate power when they're lowered back down, making them useful for balancing supply and demand in a renewable energy grid. The clean energy transition is truly a positive tipping point, and it's well underway.
What makes me most optimistic is the rapid developments we've seen in technologies like solar, like wind, like electric vehicles. If we didn't have those technologies, I'd be very, very pessimistic about the future that we were headed for.
But even with all this innovation, we're still projected to double global warming. The only way to change that is to speed up the transition as much as possible.
And we can't rely on technology alone to reduce emissions all the way to zero. At least, not anytime soon. But we can get to net zero, which means balancing the amount of greenhouse gases emitted with an equal amount removed from the atmosphere. That means pulling carbon out of the atmosphere. Tech solutions like direct air capture involve sucking up air and filtering out the carbon dioxide. But this is still expensive and energy intensive, and it'll also need time to mature and scale.
Fortunately, nature's been working on this a lot longer than we have, and its solutions are ready now.
We've dug ourselves a pretty big climate hole, and so we're going to need a combination of clever industry and verifiable, confident nature-based solutions. We're going to need both.
And some of those natural solutions can help to not only get us out of the climate crisis, but also to mitigate some of the impacts of climate change along the way.
So we're here in Florida to learn more about mangroves and how they support ecosystems and how they can help to fight climate change. So we're about to get on a boat to explore this nature-based solution.
Mangroves are unique ecosystems made up of trees and shrubs that grow in tropical and subtropical coastal areas around the world.
They're incredibly important for fish habitat, for food, for local communities, for storm protection. But they also store a lot of carbon. So you have these massive carbon reservoirs just rimming the tropical coastlines.
Okay, so we're about to land on Firecracker Island, and we're going to be planting mangroves on an eroded shoreline.
All right, let's go do it.
In addition to the carbon removal and storage provided by the mangroves that we've planted, they also help to protect the shoreline from erosion. And this protection becomes increasingly important as sea levels rise, storms intensify, and storm surges grow more destructive. But there's a paradox here. While mangroves buffer us against the impacts of sea level rise, they're also especially vulnerable to it. Mangroves can adapt to rising seas by trapping sediment and growing upward and inland, but only to a certain extent. Studies suggest they can keep pace with about 6 millimeters of sea level rise per year. Thankfully, the current rate is below that at around 3.6 millimeters per year. The bad news is that this rate is accelerating quickly. It's already more than doubled from the last century. And if we continue on our current path of greenhouse gas emissions, driving our ice caps to melt at an increasingly fast rate, it might not be long before mangroves can't keep up. And the same is true for many of our most powerful allies in the race to net zero. Temperate and tropical forests are the most effective nature-based climate solutions that we have, but warmer temperatures weaken their ability to capture and store carbon. And oceans, which currently absorb an unbelievable 25% of all of our CO2 emissions, are slowly losing their ability to absorb carbon with warmer temperatures. The stakes are high, and we need these natural ecosystems to help us get to net zero.
When we get to that place of climate stabilization, of lower greenhouse gas, what kind of world do we want that to be? You could imagine at one extreme end, a world dominated by direct air capture, where it's a lot of industrial plants sucking carbon out of the atmosphere as fast as we put it in. And on the other hand, you could imagine one where it's mostly been attacked through nature-based climate solutions, where we actually do have those forests. We kept them around. We improved the ways in which we managed our agricultural lands. We improved our preservation of grasslands. We have a healthier ocean.
But for these systems to help us actually reach net zero, we also have to help them, which means not only protecting them from degradation, but also lowering our emissions by continuing to develop and deploy green technologies as fast as possible. But this transition won't always be easy.
Solving climate change isn't going to be small and beautiful. It's going to be big and messy. We're going to have to replace our entire energy infrastructure with low carbon alternatives. And that requires, mining. It requires building things. It requires some emissions and producing these things that then reduce emissions. But when we look at the math, a solar panel is 97% better than a gas turbine.
People are looking for the perfect solution that needs no land, that needs no minerals, that has zero impacts whatsoever. And I think the reality is, if that's what we're looking for, we will get stuck, and we'll get stuck on a system of fossil fuels. But what we're looking for is environmental impacts that are orders of magnitude lower and better than our existing fossil fuel system. And the reality is that a shift towards low carbon energy and electrification will do that.
And the path forward involves all of us. In order to avoid the worst impacts of climate change and tipping points, like the collapse of the AMOC, we have to act now.
The warmer it gets, the worse it gets. Or as we climate scientists like to say, every 10th of a degree matters. It's not that the world passes a tipping point, walks off a cliff, and it's over. It's more about how much of the damages we can reduce and how intact a world we can pass down to future generations.
We know that it took too many years to convince Americans that there was risk. And now people are feeling it every day, but it's still difficult to connect the dots. We have a small window to not only convince America that there is a problem, but to convince America that we can be a part of the solution.
In the face of these enormous changes that we're already beginning to tackle on so many different levels, it's absolutely necessary to maintain a sense of hope in order to keep going. So I wanted to know how Lisa feels about the future. She's measured the slowdown of the Gulf Stream, which is likely because of climate change. She's witnessed firsthand some of the massive impacts that humans have caused.
All right.
Come on up.
Oh, wow. I'm just so curious, what gives you hope? Because this type of work can be a little depressing at times.
I know, right? It's kind of like we're witnessing the degradation of our natural world in real time.
Yeah.
But, these past 20 or 30 years, it's not just climate scientists like me who've been trying to understand the Earth system and how climate is affecting it, how humans are affecting it, but also, economists and people, engineers, people developing technology, entrepreneurs. A huge sector of people have been thinking about how we solve this issue. And so that gives me hope. You know, we know we got this. We just have to embrace change.
Over the last year, I've traveled from the Arctic to the equator, had some unbelievable experiences, and spoken to some of the smartest and most inspiring people on Earth, all to try to understand the future of our climate. And I'd be lying if I said I wasn't worried. But the stories of resilience, resourcefulness, and innovation have left me feeling inspired. From the cutting-edge renewable technologies to the vital role of our natural ecosystems, it's clear we have the tools and the ability to reach a net zero future. The only thing that stands in our way is ourselves.